Okay, so we've got our guy, and he's able to jump, and we can handle double jumping. But now we need to actually add some movement for left and right, and I'm going to use the arrow keys to actually do that. You could actually use WASD keys, W-A-S-D, and once you see how to do the left and right arrow keys, you shouldn't have any problem with that. This video is going to be about JavaScript, and we're going to build right from the v2-js build that I got from GitHub. I actually checked it right out of GitHub, so it's the same thing as what's up there. So if you check that out to start this video, you should be able to proceed on your Mac as well. So as we know, we've got our guy here, and he's got a JavaScript attached to him. And we want to actually modify that so that we'll be able to handle the keystrokes for left and right. And I'll show you a couple other things. We've essentially got what's kind of a bug in our jumping behavior. That's something we don't want it to do. And I'm also going to show you how to flip the sprite. So when we are facing to the right, as we are now, when we press left, we want to flip the sprite over so that he looks like he's facing to the left. All right, so let's get into the code. Let's open up MonoDevelop. Show you how to do this in JavaScript. And let's get in there. I should have opened MonoDevelop before I started the video. Yeah, I have like several versions working at a time. I just did the C# one and checked everything in, made sure it worked. I'll have to cut this out of the video. Okay, so MonoDevelop is open. This is our code that we had for, whoops, back to that. Oh my gosh, okay, so here's our code for our jumping behavior right here in the update. And what we want to do is we want to be able to handle keystrokes for left and right in this same update function. So we're going to go ahead and we're going to add some code for checking for the keys. And we'll just say if the input GetKey. Now this time it's not GetKey down. And the reason is GetKey down before was for every time we press space, we wanted it to check for jumps. In this case, for moving left and right, you want the character to move to the left or to the right as long as you're holding the key. So GetKey down only fires once per stroke, so we want to actually be able to hold this down. As long as that key's held down, sending the signal, we want to be able to move our character. So not GetKey down, GetKey this time. So if the GetKey is key code dot left arrow, and there we go. So make sure the case is correct, capital L, capital A. So if we're pressing the left arrow, then we want to move to the left. And the way to do that, I'll kind of show you how to do this, and we'll fix something that I know is wrong. So we're going to say get component, like we always do. So get component of rigid body 2D. Oh, not rigid body 2D. And we want to get the velocity, just like we did before with the jumping. And this time, instead of going on the y-axis, we want to do a two-dimensional vector going on the x-axis, so left and right. So in this case, I'm going to create a variable that's going to be called move speed and 0. So in this case, we have to create a variable up here. It'll be, just like our jump height. So we'll be able to change it right from the character. So var move speed equals 0. All right. So we've got our, I'll fix that back up. So we've got our max jumps, our move speed, and our jump height will all be publicly visible. we'll be able to change them right from in Unity. So the problem we're getting here is that, or that we're going to get, is that when we move to the left, we're going to stop jumping because we're going to set it equal to 0. And now that we're going to try to move, we're going to see that actually what we were doing is we were keeping our character from moving horizontally every time we jumped. So you would be, say, moving to the left, you press jump, your guy would stop, and then he would go up in the air, and then he would land. Or while he's in the air, then he would try to move, and then he would stop jumping, and this is definitely not the behavior we want. So we want to go back here. As long as you know we added move speed, we'll be able to change that in Unity. And right now we need to do something to kind of track what our velocity x was. So we want to create a little actually, I'm going to start up here outside of this, and I'm going to create a var x, and I'm going to create a var y. And these are just going to hold our x and y coordinates. And they'll be available to us within this because we're still in the same function. There's something about scoping. You can get into that and figure that out later. But get component, rigid body 2D, of course. And we're going to get its velocity dot x. And we're going to store that right in this little x variable here. And when we store that, we want to actually hold it in, we want to pass it again into here. We could put this whole thing, get component velocity x, so whatever it is, just keep it, but I'm storing it as a little variable just to kind of make this function, this whole line look a little smaller, not so long. So hopefully this makes sense. So we're going to find out what our movement is, our x movement. We're going to change the velocity equal to whatever our x movement is to jump height every time we jump, right? So down here, we're going to get a hold of the y value. So if we're in the air, we're moving, maybe we're falling, we're going to want to know that. So we're going to get component rigid body 2D, and we're going to get the velocity y value. We're going to hold on to that, and we'll pass it back once we change our movement, right? That's pretty cool. So basically, we're going to take the whole thing, and we're going to do it again for pressing the right arrow. So input, get key, key code, left arrow. All right, we want it to be right arrow. So we press the right arrow. We're going to get the y, whatever movement we have in y, and we're going to pass that in as part of the vector, telling it to move along the x-axis. All right. Well, move speed is the same here. So if we set the move speed to 10 and we're moving left, we'll go 10 for having pressed left, and we'll go 10 for having pressed right. And that's not quite right. That means we'll keep moving in the same direction regardless of which arrow we're pressing. So if we think about our Cartesian coordinates, we've got our decreasing x's go to the left, and our increasing x's go to the right. So x gets lower, subtract it, going left, gets higher, going right. So that means that our move, whatever our move speed is, needs to be less as we move on the left arrow. And the way to do that is to just change the sign of whatever move speed is. So if move speed is 10, we want to make it negative 10. If it's 2, we'll make it negative 2. So we'll put that little negative sign in there, and that'll just change the sign of whatever the value is of move speed that we pass in. And we'll leave it positive here for the right move. All right, so let's save this, Command S, and go back over to Unity, click on this guy, and there it is, move speed showed up. So that means that things are going well in the script. I'm just going to set it equal to 2, so I was experimenting a little bit earlier. It's not a very fast movement, but we have a very small block we're going to move on. So I'll just play this right now, and hopefully our guy will go right, left, right, left, right, left. There he is. If he jumps, he goes, and of course he falls off the screen, and those are things we'll have to tackle. It's terrible that the game would do that, but he can still jump, and we can move. Experiment with that again. Okay. So you're seeing how that works. I'll show you one more thing. So because we're moving left and right, we kind of notice now that even though our guy is moonwalking and we don't like that, we'll change that with some animations in the future. The least we could do is at least flip him over when he starts moonwalking to the left. So he's facing to the right, we press left, he just slides backwards. That's we could change that. That's easy enough to do. Let's go back over to our script. And what we want to do is we want to know which way our guy's facing, and if he's facing the wrong way, when we press the key, we want to tell him to flip over horizontally, so along the x coordinates. So I'm just create a little private variable here that is going to be just kind of, it's going to tell us which way he's facing. So I'm going to call it facing right, and I'm going to set it equal to true, because initially our sprite faces to the right. And we know that, we've seen it. So whenever we are going to go to the left, we want to be able to flip our guy over. So we're going to say something like if facing right, then we want to flip him over and face the opposite direction. So I'm going to create a function that's going to be called flip. I don't have it right now, but I will in a moment. And interestingly, so this is when we press the left arrow. So if we press the left arrow and we're facing to the right, then we want him to turn over. Well, what do we do if he's facing to the left? Because we're only tracking whether he's facing to the right. Well, if he's not facing to the right, we say if not, that's what the exclamation point is, facing right. And the cat wants some attention right now. Probably harder. All right. So if he's not facing to the right, then we want to flip too. We just want to flip the opposite. So we want to flip from left to the right. And we can take care of that all in one function using this one variable to just track which way he's facing. So let's create a little function down here. Function. We'll call it flip. And whoops. And what this is going to do is we're going to change sprite direction along x-axis. We're actually going to flip the sprite direction. Flip sprite along x-axis, just like that. Just all we're going to do is just flip him along the x-axis. My cat's got some love. All right, so we're just going to create this little variable that's going to store a vector, and I'm just going to call it flip scale. This is something that we're going to get from the sprite the way it looks right now. It happens to be a vector 3, not a vector 2 this time, because it also stores the z scaling. And we're going to also just create a little quick thing to hold on to our rigid body. So I'm just going to create a little lowercase r rigid body. And it's going to be a type rigid body, that's rigid body 2D, right? We're just going to use these to hold some values. The first one's the familiar one, so we're just going to say rigid body, and we're going to get that long call that we always use all the time. Component, get component, rigid body 2D. And that's right there. Oops, 2D. Make sure you select it to 2D. All right, so we've got a little handy, shorter variable for our rigid body now that we can actually use to make the rest of our calls. Right? We need to get this flip scale thing filled in, so we're going to ask our current rigid body what the scaling is. Rigid body. So ask rigid body, give us your transform, and give us your local scaling. So however he's been scaled, sized to fit on the screen or fit in the game, we want to get that. And then we're going to use whatever his x is, and we're just going to flip it so that we're going to multiply by -1 to make it face the opposite direction. So we'll just redraw the whole sprite, but in the opposite direction, in the same location. So we'll say flip scale, which is our variable. Set the x equal to, well, I'll write this out so you can kind of see it. Flip scale times, where's my star? -1. So this will flip the actual sprite horizontally. if we would apply this negative scaling. So whatever the scaling is, let's say he was doubled. If we just multiply it by -1, he'd be doubled, but in the opposite direction. And then we need to set it back to our rigid body. So we have to tell our rigid body what we did with rigid body. There it is. Dot transform. We get this transform again, and we're going to set its local scale equal to the flip scale we just made. Right? So we're going to take this little shorthand variable for rigid body that we assigned up here. So we've got our rigid body from our sprite, and we just kind of create a little less typing for ourselves. We asked it for the transform, whatever its scaling is currently, stored it in flip scale, and we can set the x part of flip scale equal to -1 times the flip scale. And we can actually shorten that up a little bit. We can say times equals, so it says multiply by -1 and assign it to x. That's a little shorter way of saying it. And then so at this point our sprite should be flipped and facing the opposite direction on our update. But we're not quite done, because we also need to keep track of the fact that we are facing a different direction. So we need to take facing right. We have to set it equal to whatever facing right is the opposite. So if facing right is true, we want to set it equal to false. So we multiply by not, say not true, so facing right equals not true. If it's false, we say facing right equals not false, which is true. So now facing opposite direction. Right? So I just press Command S to save that. And we go back over here and try to play. Well, let's see. Project contains scripts or assemblies that use obsolete APIs. What did I use? By 2D, flip scale, vector 3. Not sure what that was about. And let's say we got an error. So let's take a look at this. Unity engine component.rigid body is read-only. Alright, so this, I had this with a capital B. Let's fix that. Lowercase b. That should be good. Oh my goodness. Transform as this. Okay, so had a couple of little errors there. So transform needed an S, that was a typo, and rigid body should have been lowercase b here. So let's go back. This should all work now. I press the Command B to compile it. Looks like there's no errors. Let's press play. Jump, jump, jump. Move left, or move right. Move left. Hey, flipped. Jump, jump. Yep. And I think we could see that he actually changed direction and jumps. There he goes. Okay. All right. Great. So sorry about those little typos in this script there. You can see how I used it to fix the bugs. And let's see, what did we learn? We learned how to actually get our guy to move based on the keystrokes, so left and right. You can change these to WASD if you like. And we also learned how to flip over our sprites and face in the opposite direction using a variable Boolean to keep track of that. All right, so if this is helpful, make sure you subscribe, give the videos that you like a like, and you can follow me on Twitter and also on my website. All right, thanks a lot.